Hi folks, today we are going to talk about tangent graphs. Very, very different than the sine and cosine graphs. So we'll go through all the different ins and outs of it. Like I said, it looks very, very different, has different properties and different ways of approaching different parts of it. So let's get to it. We'll start with, and this is the note sheet that you have as well, so make sure that you're copying all this down onto your note sheet. Before we start though, let's talk about the what tangent is. Remember that the tangent of theta is going to be y over x. Okay, we learned about that when we learned about these different trig values when we had our unit circle. I'll draw that over here. When we had our unit circle and we said a point on the unit circle, the x coordinate was the cosine and the y coordinate was the sine. And that's where the tangent comes from. So we also need our unit circle for to find our quadrantal angles. So I've got 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay, so tangent is y over x. So at 0, my tangent is 0. At 90, or at pi over 2, I would have 1 over 0, which is undefined. So I'm just going to leave that blank. When I get to 180, 0 over negative 1 is 0. When I get to 270, or 3 pi over 2, again, I'm doing negative 1 over 0, so that's undefined. And then when I get back to 2 pi, that would be 0 again. Pi over 6, right? We get these out of our special right triangle, our 30, 60, 90 triangle. And if I were to draw that out right here's 30, here's 1, 2, and root 3. So the tangent of 30 is root 3 over 3, which as a decimal is 0.58. And again, the only reason I'm using decimals is because it's easier to graph. 60 would be 1.7. When we move into the second quadrant, tangent is negative. So this would be negative 1.7. This would be negative 0.58. When I'm in the third quadrant, tangent is positive. And when I get into the fourth quadrant, tangent is once again negative. Okay, so that's what that's the values. So let's go ahead and put in our asymptotes first. So I have one at 90 degrees, or at pi over 2. Then again at 3 pi over 2. Draw that in there. Which would mean I'd also have it at negative pi over 2. So at negative pi over 2, I have one, and at negative 3 pi over 2, I also have an asymptote. If you notice, I have zeros at multiples of pi. So at 0, at pi, at 2 pi, I'm actually crossing the x-axis. So that would also mean at negative pi and negative 2 pi as well. So if you kind of just think about it sort of analytically, you'll see that every pi over 2 interval, it's alternating between 0 and undefined. 0, undefined, 0, undefined. Okay. Let's then talk about at 30 degrees, I'm at 0.58. At 60 degrees, I'm at 1.7. And let's see, at 120, I'm down at negative 1.7. And then I'm at negative 0.57. And then I'd be at 0.57, and then at 1.7. So here's kind of the shape of the graph. I'll do it in a different color. I'll do it in blue. So you can see what happens is the graph does this. And again, you have to forgive my bad drawing here, but it's a swoosh kinda. That doesn't look very good. Let me redraw that. It's like a kind of swishes. Swish, swoosh, however you want to call it. So basically it ends up doing this. It kind of comes up, curves, and then goes up from there. Up like that. And then it would do the same thing here. So it would go like this, curve, and then go up. And it would do the same here. It would curve and go up. Oops, up like that. Up. It won't actually intercept the asymptote. It just kind of curves. And here we would have this, and it kind of curves like that. So that's what my really bad drawing looks like, but that's what the tangent graph looks like. Okay, so it's discontinuous, very different from sine and cosine, right? Sine and cosine, you could draw the whole graph to infinity without ever having to lift up your pencil. Here, this is discontinuous. Okay, but we know where it's positive and where it's negative. That's supposed to say tan there. We know where it's positive and negative, where it's increasing and decreasing. We know the values of the quadrantal angles. We know where it's discontinuous. Here's a big one. It has no amplitude, no maximum, no minimum. If you look at the graph, right, it goes on and on forever in the positive y direction as well as the negative y direction. So it has no amplitude, no max, or no min. The domain is all real numbers, and then you see this funky little notation in there. What x cannot equal. Okay, so it cannot equal multiples of odd multiples of pi over 2. So at pi over 2, right, I have an asymptote. At 3 pi over 2, I have an asymptote. Then again, at 5 pi over 2, I would have an asymptote. At 7 pi over 2, I would have an asymptote. So if you think about this right here, 2k plus 1 is just simply a way of expressing a number as odd, because no matter what number you have, whether it's odd or even, if you multiply it by 2, it becomes even, and then when you add 1, it becomes odd. So that's all that means, okay? So this just means odd multiples of pi over 2. Our range is everything from positive infinity to negative infinity. And here's something, the translational symmetry and the period, it kind of means the same thing, is pi, where sine and cosine it was 2 pi. For tangent, the period is pi, which means you complete one whole cycle in pi radians. If you're looking at the graph, right, one of these swishes is a cycle. So from pi over 2 to 3 pi over 2, that's pi radians. That's one cycle is completed. So that's your period. The graph is a function, right, but it's not a one-to-one function. So the key values when sketching your tangent graph are your zeros and your asymptotes. And like I said, remember that it alternates. It alternates between asymptote and 0. And also notice that that 0 is halfway between those asymptotes. Okay, so that's really important. This is really going to help you out when you're trying to graph different variations. So when we're changing the frequency, it's going to help us to graph it out. Okay, so let's look at an example. So that is the graph of just tan of x. But what happens when I have y equals 2 tan x over 2, when x is between negative pi and pi? So a couple of things. I just happen to use x here. Sometimes you'll see the angle represented as theta or some other letter. Okay, that's arbitrary, just kind of what I happen to pick for this problem. Another thing, the 2 really doesn't matter, right? Because that's in front, so that's indicative of an amplitude, but this doesn't have an amplitude, so that's really not going to do too much for us either, okay? As far as a maximum or minimum, because there isn't going to be a maximum or a minimum. Okay, so how are we going to go about doing this? If you look at the original graph of tangent, right? We knew that the asymptotes were at multiples or odd multiples of pi over 2. So if we kind of take that whole idea and I say, well, I know that I can't actually ever equal pi over 2 or 3 pi over 2 or whatever, but I know I can be between them. But because I'm looking between here, negative pi and pi, I'm going to look at these two asymptotes here at negative pi over 2 and pi over 2. Okay, so I'm only using the interval that I'm going to use based on what they're saying in the given problem. So because they want me to graph between negative pi over 2 and positive pi over 2, I'm going to write where my asymptotes are of the tangent graph between those. I know I have asymptotes at negative pi over 2 and positive pi over 2. So I'm going to say, all right, well, that must mean that x would be between, or my angle would be between negative pi over 2 and pi over 2, but not actually touching them because I have asymptotes there. In this case, my angle is x over 2. Okay, so understand what's happening here. I'm just saying whatever my angle happens to be, it has to fall between negative pi over 2 and positive pi over 2. Okay? And so what happens if I want to solve this for x? If I multiply everything by 2, I get from negative pi to pi. That's where my asymptotes are going to be. So all I did was found my asymptotes. So even they said here where they wanted me to graph it, but they didn't tell me that the asymptotes were there. I had to figure that out, okay? They could have said from negative 2 pi to positive 2 pi, but they didn't. They said from negative pi to pi. All that means is that's where they want me to graph it. I had to find out where the asymptotes were. So I know that the asymptotes then are going to be at negative pi and positive pi. Oops. Now, if you didn't want to do it this way, or if this is confusing, you could just think about it like this. I know that at x over, or excuse me, at whatever the angle would have an asymptote at pi over 2, then you could just solve this for x. You could say, oh, okay, well that means I have to think about it when x is pi. Not that x is pi, but this is, we can just say, well, the angle would have an asymptote at pi over 2, and you could think of it that way as well. Okay? All right. We also said that the 0 is going to be halfway between my asymptotes. So if I have an asymptote at negative pi and positive pi, that means my 0 is going to be right at 0, halfway between the two asymptotes. Okay, halfway between the two asymptotes. Now, find some points on the graph that are kind of halfway between the 0 and the asymptote. Okay, so basically what I'm trying to do is figure out what the value of tangent is at negative pi over 2 and at pi over 2. Okay, so that's what I'm going to be looking at. I'm looking for my tangent here because that's halfway between the asymptote and the 0. At negative pi over 2, I'm halfway between them. At positive pi over 2, I'm halfway between them as well. So all I'm going to do is substitute in, right? I'm just going to substitute in pi over 2 for x. So I've got y is equal to 2 times the tangent of pi over 2 over 2. Okay, that's the same as 2 times the tangent of pi over 4. Pi over 4 is 45 degrees. The tangent of 45 degrees, that's one of your special right triangles, is 1. And so I then take that 2 and multiply it by 1, so I get 2. So at pi over 2, I'm up here at 2. Okay, I'm going to run out of time, so I'm going to pick up the rest of this in the next video. Thanks, folks.